6 to the x equals 42. It's time to finally start solving log problems, or at least estimating them as best we can. Mr. Combs, I have great confidence in you.
Yeah.
Tell me what to do.
I was thinking maybe we're going to continue to do the log of the log thing.
Yeah, how do we do that?
The log of 42 on top.
Okay, so you're going to swing the 6 across by definition?
Yeah.
Okay, so it's going to be x equals log base 6 of 42. Agreement?
Yeah.
All right, and then that becomes log of 42 over log of 6. Love it. Oh, look who decided to show up.
Oh, yeah.
You took away your seat.
Oh, wow. Wow. Oh, nah, that's okay. It's fine.
Just keep the Bible.
Is that right?
Yeah.
All right, let's do it a different way. Did anybody do it a different way, by the way? Did anybody have a different way to do this problem? All right. I'm going to challenge you to use log natural. And I'm going to challenge you to do it in a bold way. We're going to just log natural both sides right from the beginning. What do you got?
Log 6.
Log natural of 6 to the x equals log natural of 42. Agreed? All right. I need to get the x out of there. How do you get the x out of there? You know how.
I don't think so. Oh, do I move it to the front?
Yeah.
Oh, yeah.
Now I want to solve for x. What do I do?
Plug it in. Oh, no.
Oh, I could. I could do that. Or I could divide it across first. Or I could do it. Let's do it. I am not saying you're wrong. That is not wrong. I'm wrong to say you're wrong. That's wrong. So 1.7918 x equals ln of 42. 3.7377. Is that right? Then I'm going to divide the two. 1.7918 and x equals 2.086. Look at that.
The way that you're in there, you're going to divide by 6.
That's what we ended up doing, right? Because if you divided ln 6 to both sides, you're basically at this step, except we used ln this time instead of logs. Doesn't matter, you could use logs. Which is a better way to do it, sir?
Left side.
Left side, because that's the way you want to do it. That's fine. So okay. All right, keep going. Do problems. We got 8, 9, 10, 11, 12. Ooh, warning, 10's an inequality. We got to remember how to do inequalities. No! I mean, no thanks. That's not an option. What? This can't be done. Can't be done. Coach can help us out with this one. You ready?
Sure.
Is everybody else ready? All right, let's do this problem. Let's do it.
You move the 7 to the other side.
You're going that way? Beautiful, by the way. So that gives me x equals log base 7 of 4 to the x plus 3. Holy monkeys. Now what?
Can you have log 4x plus 3 over log 7?
Yes. Before I do that, though, I'm just going to go ahead and move the x plus 3 out of there, all right?
Okay.
Can I do that? Okay?
Yes.
All right, let's do it. And then I'll put your step on there for you. Or do you want to use log natural?
No, log is fine.
Log's fine, all right. Woo. Log of 4 divided by log of 7. I got x equals x plus 3, 0.71241. Now, ironically, some people have trouble with this part. You know it's algebra 1. What do you want to do?
You just multiply the two.
Yeah, how? Distributed property?
Yeah.
Okay, all right, I can do that. As long as you got a way to do it, I'm not that picky. Plus, times 3, 2.1372.
And then you move the x to one side.
Yeah, I gotta subtract this 0.71241, right?
Yeah.
And I'm getting 0.28759, x equals 2.1372.
And then you divide the 0.28 by the other side.
Oops. Delete. So 2.1372 divided by shift answer, and I get x equals 7.432. Another approach that works as well, log both sides. Then you get x times log of 7 equals x plus 3 times log of 4. Put both in your calculator, you're doing algebra. Either one of those is perfectly okay to do. Nothing wrong with either approach. They both get you to the finish line. They both are almost always going to get you to the finish line, which way you go. Okay? Cassini good?
Yeah.
All right. And I think you got 9 and 10 are both worthy of a discussion right after you do them. So make sure you do number 9 and number 10. All right. Tippins. All right. So you have good algebra skills, right?
Sure.
What are the instincts your algebra skills tell you to do? Because I'm trying to get to that T. What should I do first?
Move it to the front.
I can't move it far. It's not a log.
It's the base.
By the way, there's almost no wrong answers to the question I'm asking you. They're just kind of a better way to do it. It's a little quicker. Divide by 175. Let's start there. So I've got 1249 divided by 175, and I get a whopping 7.1371 equals e to the negative 0.04t. Okay, so now I've got to get that exponent down, don't I? How do I get that exponent down? Hold on a second. How do we always get an exponent down?
Oh, root it?
Okay. What? No. No, we got two choices. One, use the definition of a log. In other words, swing the e across. Whee! And that drops it down, right? Or two, we can pick some random number and log both sides by it. Let's move it over. So you use the definition of a log. So for those of you at the home game that said, I logged natural both sides, Mr. Rezzi, that's fine. But she's going to do it this way, which means log base e of 7.17371 equals negative 0.04t. Log base e is really secretly what? ln. So I know I have a button for that, so let's use the button for that.
And then divide negative.
And I got a whopping. I got negative 49.133 equals t. Way to screw that. Yes, sir.
On number 10, is there a number or like a log thing on kind of?
No, it just says 10
Okay.
to the x plus 1 is greater than 3 to the x. Solve for x. Whee! Log of 3 to the x would be so far. That's one option. Option 2. Swing the monkey across. X plus 1 equals log base 10 of 3 to the x. I swung the 10 across. Or option 3. Option 3 is 10x plus 1 log base 3 of x. Door number 1, door number 2, door number 3. You may pick which way we go from here.
I'll do 2.
We're going to do 2. 2 is our winner today. All right, we're going to do 2. So I'm going to get that exponent out of there because I don't like where it is. Boom, put it in front. I got x plus 1 equals x log base 10 of 3. Log base 10 is what? That's our normal button, isn't it? So hit log of 3. Let's see what we get.
0.4771.
1 what?
2.
2. All right. Keep going.
Divide that or no? -1.
All right, I'm good. What?
Minus x.
Minus what?
Isn't there an x on
There's
the
an
other
X on the
side?
other side.
Oh, there's x on the side. Okay, now that makes me feel so much better. Okay, take back my cackling laugh. What? What do I do now?
Minus x.
Minus x. Okay, we'll go negative. 0.52288x. Negative.
And divide by that.
Yeah. Sorry, I'm glad you saw the x there. I felt bad. I thought you were actually struggling with what to do with the plus 1. That's on me. 1 divided by negative 0.52288. What I got? To what I got?
-1.912.
2. Okay, now it's equals 2, but that is not where we're stopping this problem, is it? Because this started as an
Inequality.
inequality. So now I'm going to draw my little mini number line.
Oh.
Wow, that's like you guys all worked that out
What
together.
chapters did we do these in?
Chapter 1.
Oh, it's
We didn't do this, but we did all sorts of exotic functions, and then we went to sign. I said, hey, remember chapter 1? You just set it equal, and then just pick a point, and you pick a point left and right. It can't be equal to negative 1.912. Yes, sir.
Oh, can we do the first one after?
oh my god. It's
Sure, absolutely.
negative.
So you're just going to pick a point to the left or a point to the and a point to the right. What do you got for me?
-1. Or 0.
Oh, dear God. Yes,
Yeah.
0. Thank you.
I was like thinking
You meanie pants.
that it was like.
A negative 1 might make that a 0. Yeah, I'm not completely against that. Okay, so if I put in a 0, I get 10 to the first is greater than 3 to the 0th.
Yeah.
That's 10 is greater than 3. Oh, 10 is greater than 1. Is that true?
No.
That's true. So I'm going to think that x is certainly greater than negative 1.912. But I should check the other one out. How do I check the other one out?
-2.
Negative 2, and I get 10 to the negative 2 plus 1 is greater than 3 to the negative 2. That gives me 10 to the negative 1 is greater than 3 to the negative 2. What is 10 to the negative 1?
1 over
You're not putting your calc. There you go. 1 over 10
and
is greater than
2.
1 over 9, right? Oh, that went too fast. That was way
Oh,
too
no, I got
fast.
it, yeah.
No! You don't got it. I'm going to put it on the bottom. 1/10 is greater than 1/9. Is that true? No, so that's not true. So therefore, this is the only place it is true. Or I can write it as negative 1.912 curved bracket to infinity, because I like that better. I'll do that, and then I'm going to do it the Combs way in just a second. Is that okay, everybody? Everybody got that? The last steps, at least?